performance monitoring. In this nugget, we talk about performance, and we start off with really system monitor, which is also known as sysmon or performance monitor. So this is what's going to allow us to keep track of various kinds of performance capabilities within your server. And we'll look at some various common counters that will allow us to be able to look at those things. Then we'll look at various logs and alerts, which will also be able to allow you to archive the performance over a period of time, and also give you an alert if a certain event takes place or a certain kind of a performance counter takes place that you want to be aware of. For example, maybe your processor is overutilized or you're low on disk space. Then we'll look at WMI, which is the Windows Management Interface, and this allows you to get into very detailed and deep performance monitoring, and we'll just take a look at the surface of that and see how we can use it to, for example, output a report to an HTML page for us. Then we'll take a look at the command line utilities that are also available for performance monitoring. Picture this. You go into your boss's office one afternoon and you say, hey, you know what? Our users are complaining that their TPS reports are taking an exceptionally long time to generate off of the SQL server. That's a little bit of an inside joke for those of you that have ever seen a movie called Office Space. Anyway, so they're taking forever to generate these SQL reports, and your boss says, wait a minute, I don't know what the big deal is. I usually run mine when I get in. I kind of an early bird, so I'm here at 6:30 every morning. I generate my reports. It only takes 20, 30 seconds to get my reports. How long is it taking your users? And you say, I don't know, they say it's all taking a long time. Everybody's complaining that we need a new SQL server. So I figure about $10,000 ought to cover it, you know, a dual processor SQL server, plenty of storage and all that. So if you could go ahead and cut me a PO, we'll go ahead and get that taken care of. Your boss says, wait a minute. You know, corporate's coming down hard on our budget. We're counting pennies like they're diamonds, and you want 10 grand? You're going to have to give me more than just everybody says it's slow. And you know what? He's got a point there, and that's why we have to use things such as performance monitoring. So what we use here is under administrative tools, and something called performance on the shortcut here. Now, performance is also known as system monitor. And in this system monitor item, we can keep track of key counters, and there's a few included there by default, and it keeps track of these counters on the local machine. And of course, you can add additional counters and additional counters for remote machines if you like as well. Part of this performance console also includes performance logs and alerts, which includes these other items which we'll cover separately. Now, the performance monitor that we see, or the system monitor, whatever you want to call it, is what's going to allow us to keep an objective view of the kind of data that's being collected. And we can use this to justify expenditures, to analyze the performance of certain applications, see whether or not we have memory leaks, all those different kinds of things. And in order to use this, basically there are three that are included by default which keep track of the key elements within a system. One of those is memory, the other one of those is processor utilization, and the third one is your disk utilization. Well, this first one, pages per second, identifies how many times information that is supposed to be in RAM has to go out to the paging file instead. So we see how many times it has to page per second in order to retrieve information off the much slower temporary memory of your paging file. Now, we also see average disk queue length, and that means how many outstanding requests are out there waiting to be serviced by the hard disk. And for this, we usually want the number of spindles plus 2 as your maximum threshold. So if I have just one spindle, my maximum average disk queue length probably ought to be around 3 or less, and we wouldn't want it to be much higher than that. Percent processor time relates to just that, how busy your processor is servicing various tasks, services, and applications. Now then, I just went ahead and clicked on this button, which starts a new counter set, and basically that means it clears everything off that we'd had, and we start from scratch. So I just do that so I can show you the kind of counters you can work with. We will click on Add here, this little plus button, and we can identify computers that we want to monitor only locally, which locks us into DC Nugget 1 in this case, where I'm locally seated, or you can specify a certain server in this list here. And it can be any machine that's monitorable, which would be like a Windows XP, Windows 2000, Windows NT, but basically any current version of Windows is available to monitor. Then you specify the performance object. In this case, this goes from general to more specific to most specific. The general is whatever category of hardware, a category of network performance, or anything like that I want to monitor. So you can have processor, you can have physical disk, you can have network interface, which would do things like show you the throughput of the server for the network utilization and all that kind of stuff. Then you specify which specific counters or which specific items about the processor you want to monitor. In this case, it would be kind of a shotgun blast to choose all counters. That might give me more information than I could feasibly wade through in a practical fashion. So I'll select a specific counter from the list, percent processor time, which is one of the default counters that was there already before I cleared the list. Then you specify which instance you want. You can choose all instances or selected instances from a list. Now, I only have one processor, which is ordinally numbered as number 0 here. If I had two processors, it would be 0 and 1. In this case, it doesn't matter what I select, so I'll just choose whatever we've got here, 0, it doesn't matter. And then once I click on Add, it will add it into the background over here to all of my processing, or rather to all the counters that we're using. So then I went ahead and added in this processor time, and I'm going to go ahead and offline here, add in a few other counters, just so we can see some system activity on here and have something to work with. So now I'll go ahead and just add what we've got here, and I'll add a couple other, one or two other items here as well. Let's go ahead and go to the paging file, and there's going to be an explanation for all of these counters, by the way, a little bit later on, because these are quite involved, some of them, in terms of their description and all of that. So go to the paging file, we'll add that one. How about we also add, threads, so we can see how many threads are going on. Applications, when they need processor time, they have to use a thread, which is kind of the string that attaches them to the processor and allows them to get information or get dedicated time from the processor. So we'll just add that one as well. And then what I'm going to do is just launch a little applet here that you'll be able to see some activity in System Monitor. This is an old Windows 95 utility called WinBez-MT. And what we do with this is simply this: press Control-T to add Bezier curves. That's it. They really serve no useful purpose in life other than to make you dizzy. And you can add up to 63 of these, so I'm just going to hold down Control-T and add a whole bunch of these up to 63, and I'm just going to tile all of these. Now, this used to be a lot more dramatic back in the days of Windows 95, when we had really slow operating systems and really slow hardware as well, where you were struggling to find machines that were, 100 megahertz and all of that. Then this would really slow down to a crawl, and the system would just about crash. Well, now we have faster processors. I've got over 2 gigahertz on this machine, so it's pretty fast. And we do see, however, if I go back to performance, that my little counter up here goes all the way to the top. And I may also notice that it was appearing in white. That's because I pressed Control-H on the keyboard like I did just now again. And that helps you to keep track of all of the different counters, because it kind of becomes a little bit difficult to keep track of them all if they get jumbled up in here and you got dozens of little colored lines intersecting with one another. Now also be aware of the fact that at least in this view, you only get 1 minute and 40 seconds worth of information. That's because it ticks across over here, this little progress bar ticks across one increment at a time. There's 100 increments. Of course, 60 seconds plus 40 seconds, 100. There you go. So this is all right just for a brief period of time, kind of almost a snapshot view. But if you really need a longer period of time that you can view this at, for example, a whole working day, that would be 60 seconds times 60 minutes times 8 hours. So that would give you, if you divide that by 100, you'd be at 288 seconds for your incrementation here. So how do I change this duration? Well, go to any one of these counters, doesn't matter which one, and go to Properties. And then you can see that as we go to this initial view here, you can change things like the color and the size of the scale and the width and of the markers and all that kind of stuff, the width of the little lines and all that. But what we're interested in here is going to the General tab, where you can, again, change the views of different things, which pretty well, I think, explain themselves. But what we want to do here is to change the sample to automatically every 288 seconds, which would give us, as you can see here now, 8 hours worth of data. And so that might be useful if you need to get a look at a trend. And if you see over here at 3 o'clock in the afternoon, it seems to get pretty high, and then it tapers off. And then you know when you can do certain functions on that server, when it's most busy, when it's least busy, and things of this nature. Now, we're going to be talking about this later on. But if you need longer-term trend analysis and you want to save this data, then you're better off to use a counter log instead of just this graph view that we see here. Now, another thing you could do is you could go up here to this button, which would allow you to freeze the data. So if it was going on every second creeping across here, and I wanted to just stop it for a second or freeze the data so I could just look at something and analyze it, just click the button. Once you're done freezing the data, you go back to updating the data to its current counter, and that will just allow you to incrementally creep along at whatever you want to do in the time frame that you want manually. And then I can unfreeze the display so it automatically starts counting, in this case, every 288 seconds. Now you can see that here offline I've gone ahead and stopped WinBez because it was consuming all my CPU cycles and all of that. And if we look at this, we say, you know what is a good utilization of the processor? Here I've got 51%. Is that good? Is 60% good? 70%? 80? 90? Which number would be too high for an average processor utilization? Well, that's kind of a subjective thing in some cases. I mean, if I have online transaction processing that's taking internet orders over the internet, and I've got to make sure that those clients are serviced very quickly, then I probably want a very, very low number with this. But if it's just generic network functionality for some function, and as long as the data gets there, it's not that time sensitive, we're okay, then I might be willing to handle up to 80%. You probably don't want to go over 80%, by the way. Now, especially though, how about these other numbers, any of these other counters? How do I know what number would be acceptable? Well, I have to give Microsoft credit. Here, if you go to Help and Help Topics, Microsoft's done a pretty good job under Performance Logs and Alerts and then Concepts of giving us a good starting point for tracking the performance of our various counters. Go to Using Performance Monitor, Performance Logs and Alerts, and then go down here to Analyzing Performance Data. They give a table here of a lot of suggested thresholds for the minimum suggested threshold for your performance of your system. Now then, having returned to the Add Counters window here, we see that if you look at the performance object, and then you look at all the various counters that are in the list down here for each one of the objects and all the instances, man, there's hundreds of counters and things to keep track of here. Which ones really matter? I mean, some of these are pretty obscure, and probably no administrator will ever use them. However, some of these are also key, and which ones are those? Well, just remember that you're keeping track of 4 key resources: disks, memory, processor, and network. Those are the things that you want to keep track of to make sure that a server is performing up to snuff. So let's get started with the logical disk counters. Now, let's go, as we go to logical disk counters here, one of the things we're really interested in is this one, percent of free space. Now, you can look at that as a total instance for all of the disks at once, all of the logical drives at once. However, that might not give you an accurate picture because drive C might only have 5% available disk space and really be in jeopardy. However, all these others have, 40% free disk space. Well, if that's the case, you're not going to see a counter reading here that's going to alarm you. And what you want to see is something that alarms you, quite frankly. So I would track each one of these individually. And then you'll be able to get an idea of when you have a problem. Now, this kind of thing is also good if you want to create an alert. This is kind of a good kind of an alert to keep track of as well, and we'll talk about that also later on. And with an alert, it'll just alert me, maybe send me a net send message or something like that when drive C or whichever one of these I'm monitoring gets too low on disk space. Also, you don't want these to get anywhere below 15% for most purposes. And again, it's relative to the kind of work that your servers are doing, but that's a general rule of thumb. 2 reasons why you don't want to get too low. Number 1, as it gets too low, let's say it's at 5%. Well, that also means that you have very few spaces of available free space on that hard disk. And if you're trying to save a large file, it's going to have to cram that large file in little itty-bitty tiny spaces throughout that disk, and it's going to have to really scramble to find available free space. Number 2 is for defragmentation. Unless you've got more than 15% disk space for free for defragmentation, it makes it very difficult to make a good defragmentation run. Now let me also point out that the online help, if you click up here on help and you navigate your way to analyzing performance data, it does have an error in the documentation. It says that there is a physical disk counter for percent free space. There is not. So just bear that in mind. If you're driving yourself nuts trying to find it, it ain't there. Now let's take a look at another counter that's very important for disk utilization, and that is physical disk counters. And the reason why I'm switching now from physical disk away from logical disk is this. If I want to keep track of, for example, the percent disk time, which is an analysis of how busy that disk is, how often it's reading and writing data. Is it reading and writing data 50% of the time? Is it reading and writing data 90% of the time? As a rule, you don't want to go above 90%, again, relative to the kind of functions that you're performing. And that's the good starting point, 90%. Now, remember that drive C, E, and G are all on the same interface. And we might have seen that when we looked at the disk portions of our nugget earlier in this series. And since all of those disks are actually on the same physical drive, that's going to cause a problem if I try to analyze disk time individually here under logical disk. Because drive G is going to be every bit as busy as drive E and C in actuality, since they all exist on the same physical disk. It's not going to give me an accurate picture of what's really going on here. In fact, if I've got a large database on drive G that's fairly busy, when I look at drive G under this counter the way I've got it right now, I might say, I don't know what everybody's complaining about. It's not that busy. However, drive C and E might also be exceptionally busy, and since they're on the same physical disk, it's going to affect the performance of drive G as well. So when you're looking for counters like this, normally you want to try to shy away from logical disk, and instead you want to go to physical disk. Now that I've gone to physical disk, percent disk time, I can get a much better reading because now I'm going to my second disk drive, which is ordinarily numbered number 1 here, and now I can get the physical disk performance characteristics for all of these combined, these logical disks combined on that same physical disk. Very realistic picture that way. Another counter to keep track of here would be disk reads per second and disk writes per second. So we have reads and writes per second here. And what this would do is help keep track of the I/O operations going on that disk. Now, this partially relates to the manufacturer specifications for a given disk and what kind of an interface it has. For example, whether it's IDE or SCSI. Most of your servers are probably going to be on SCSI. With an ultra-wide SCSI disk, it probably can handle somewhere between 50 to 70 I/O operations per second. Again, depending on what kind of functions you're taking care of there. So if you see a disk that appears to be performing badly, at least in your subjective terms, and you compare that with the disk reads and writes per second, and indeed the counters are pretty high up into that range, then you might add another disk to an array or something like that to help offload some of the burden. Now then, one of my favorite counters here for monitoring disk performance is actually a different one called current disk queue length. And so let's go up here to current disk queue length. This is kind of like, it's at the holiday season, and you're at the post office, and there's a giant line there. And so you go up to that little spindle with the paper things on it, and you pull off a number, and it says number 99, and you look up at the little counter up there that's lighted up, and it says they're on number 50. So you know you got a while to wait there. Well, that's the same thing that's going on with the current disk queue length, because it will show you how many people are waiting in line. In other words, how many outstanding requests for read-write operations to that disk are just waiting to happen, and they can't take place yet because the disk is too busy. And for the threshold with this one, you want to keep this number at the number of spindles plus 2. So here I've got a single spindle plus 2, so my current disk queue length should not exceed 3 for this kind of a disk operation. Now, these disks are all logical drives on the same disk. However, if this was a SCSI disk, something like, a RAID configuration, and perhaps these were all in a stripe, then I would have the number of spindles, that's 3 spindles, plus 2, that would be 5. So my current disk queue length for I/O operations here could be a maximum of 5. Now, of course, as it indicates, it's current disk queue length. So that's what's going on right this minute. If you want to get an idea of what's taking place over time, then you can go to a different counter, and that would be average. Where is it? Average disk queue length. There it is. That would give you whatever your length of time interval is. For example, if it's 1 minute and 40 seconds like we see right now, then that would give you the average disk queue length over 1 minute and 40 seconds. Now let me also point out that unlike times in the past where you've had NT4 and Windows 2000, you no longer have to go to a command line and type disk perf-y to enable disk activity or disk monitoring on local physical disks or logical disks. Instead, that's already enabled by default, and it's no longer necessary to turn that on. Now here I've switched over to the memory performance object where we have available bytes, kilobytes, or megabytes. And Microsoft's suggested threshold for large memory computers is that you should have greater than 4 megabytes of available memory here. I think that's awfully low, especially when you consider that today's servers don't have 512 megs of RAM anymore. Nowadays, we're talking often in terms of gigabytes of installed RAM, and if you have gigs of RAM and you have only 4 megabytes left, wow, that's quite a ratio of consumed memory. So it kind of depends on how much RAM is already in the system and what kind of purpose it's being used for, but at least that's Microsoft's answer, that you should have greater than 4 megabytes. Now here we see I've switched down to pages per second, and this is very useful if you want to see whether or not the paging file is being used too much, which means that you have a low memory condition. Now with this item, it's actually going to track the rate at which pages are read from or written to the disk to resolve a hard page fault, and that's when it's trying to access something that's supposed to be in RAM, but it's not there, and it's instead had to go to the paging file. And here again, as a general rule of thumb, the value here should not exceed 20 pages per paging file. Now here I've gone to the paging file where we look at its percentage of usage. Now generally speaking, and this is again just a rough starting guideline, you don't want to go above 70% usage for that paging file, but again it's very relative. Because if I've got a gigabyte size paging file and I'm using 70% of it right now, that's 700 megabytes of data that's in the paging file that my applications and system have to page to and from. So even though that doesn't exceed a threshold of 70, that's still a lot of paging going on. It's still going to affect my disk activity and might in turn also affect my applications that have to read and write from that disk. So again, you have to kind of keep these things in mind, but once again, it's about 70% as a good starting point. Now here I've switched to the processor performance object where I'm looking at the percent processor time, and this is a pretty good snapshot for determining how busy the processing is right at this current time. Now you can also track this over a period of time. However, I would not do a lot of alerts on the percent processor time because it will go to 100% quite frequently, and you should not be alarmed by that. The thing is, you don't want this to go above about 85% on a regular basis or on an average. And this is also, again, somewhat relative. I mean, if I have two database servers, one of them is a gigahertz processor machine, the other one is a 2 gigahertz processor machine, and they're both running at, say, 70%, well, that might not be sufficient performance for my 1 gigahertz processor machine because it's only able to produce so many database results using that 70% of the gigahertz processor. However, my 2 gigahertz processor, while it's performing at 70% of its utilization, it's pumping out twice as many results. So again, it's all somewhat relative to what kind of hardware you have and what your requirements are. The interrupts per second, which I've skipped to here, refers to the number of times per second that hardware in your system has to interrupt the processor to get a service request. And this is what it has to do if it wants to get attention from the processor. Now, this is going to happen in kind of a background noise fashion already. Anyway, most of your hardware will periodically kind of interrupt the processor just in kind of a keep alive fashion. For example, even your system clock is going to interrupt the processor about every 10 milliseconds, which is, I guess that's 100 times per second. So that's going to account for some of this. However, if you see that the interrupts per second go to around 1,000 per second or more, then you want to start getting suspicious of your hardware because when it starts to exceed that, that could be an indication of faulty hardware. For example, a network card, if it starts to fail, it may interrupt way too much, and it may slow down the processor because of all the excessive interrupts. And in that case, you might want to replace the network card if you suspect that's where it's coming from and see if it brings down the number of interrupts per second. Now, similar to the disk queue length that I talked about earlier, if we go to the server work queues, this will tell us whether or not the processor is too busy when we go to the queue length. If the queue length is any higher than 4, and actually even 4 is a little bit high, then that means that there's 4 outstanding requests that are just waiting for the processor to get enough free time to service them. And so you don't want to exceed 4 as a maximum starting point for this counter. Now, you'll use the same kind of an idea if you have multiple processors, but this time you'll go to the system performance object where it'll collect all of your processors using the processor queue length, and generally speaking, you don't want this to exceed 2 as a maximum outstanding number of requests to the processor. Now, to track the network performance, we go to the server performance object where we look at the bytes total per second, and this tracks the network activity to and from this server. You don't want this to exceed the maximum practical throughput of your network. So, for example, if you're on a 100 megabit per second network, generally with Ethernet, you don't want that to exceed 30% utilization. So if it starts to approach 30%, you might need to think about putting in a bridge or putting in a switch or some other kind of item there that would break up your collision network, such as another router or something like that. And then, of course, another good place to go for analyzing network performance is to go to the network interface performance object, where you can look at the bytes received per second or sent per second, depending on what your server primarily does, whether it's a web server and it's primarily sending data, or whether it's a file server and it's primarily receiving data or anything like that. Or you could just go a total per second, which would be a combination of both counters. Now, in the previous nugget, we looked at printing, and this is an excellent place to keep track of how well your print server is performing. Here we go to the print queue, and we see the number of bytes printed per second, which gives you a raw counter of the actual number of data sent to that printer at a time. Then you can look at job errors as well. Now, not all print managers will be able to report job errors, so this may be a 0, even though you're actually having job errors occur. This just depends on the vendor and the driver and things of this nature. Now, if you do get some errors with this, this is often caused by a printer port configuration error, so keep an eye on that. You can also get an idea of the number of jobs that go to that print server. It doesn't really take into consideration the complexity of the jobs or how many pages are in the jobs or anything like that, just flat jobs. Then you can also see the number of jobs that are spooling, and this is an instantaneous counter. It's not an average or anything like that. So you can see in real time how many jobs are spooling on this print queue. It also helps you get an idea of how busy it is and how long it takes to process the print jobs, because the more jobs that are spooling at a time in the background and that are backed up, then the busier that printer is, or the slower that printer is, and not able to perform up to performance standards. Then you can also look at maximum job spooling, and this will give you the maximum spooled number of jobs since the spooler service was last started or since the server last started. And then finally, I also like to look at the total jobs printed, which just gives you, again, the number of jobs sent to the printer. This is also an item that will identify since the spooler was last started or the server last started. And I say both of those because when the server starts, of course, the spooler service starts. So whenever you started the spooler service last or whenever you restarted it. And then the total pages printed is also an excellent way to identify things such as how much that printer is utilized in actual physical printout. And this will also be tracked according to the last time the server was started or the spooler was started. And in addition to that, I've also gone to this performancecounters.doc item, and I've created this document, which you'll be able to find up on nuggetlab.com. And with this, it'll give you various performance objects and counters. There's about 6 pages of all these things, which I've pasted in explanations from Microsoft's text, and this will be from Microsoft. If you see anything in parentheses down here, like this item here, that would be something that I have added on my own. So anything above the main paragraph text there will be something that I've added. So this will also be a good place for you to just read information about the various kinds of counters. There's quite a lot of information here. Just go at it and get a good idea of what some of these things are. Now, you don't have to memorize these except for possibly the main items that we've seen here, the processor utilization, the page file utilization, and certain memory counters. But beyond that, you really don't have to memorize those. You just know how to read what you're looking at and know how to interpret the data. Well, here you see that I've also gone to a Microsoft website, Microsoft TechNet, and you can see the various paths that I went through to get to the current location: products, technologies, Windows Server 2003, so on and so forth. You want the Windows Server 2003 deployment kit, and then once you get there, you want to identify and locate the Windows Server 2003 performance counters reference. The reason why I want you to get here is because this gives you a pretty exhaustive description of all of the counters. And this is extremely detailed, and if you need real detailed information, this is a place to go because there are hundreds of those counters, and that's way beyond our scope to describe each and every one of them. So this gives you all those different items. Now, another important use of monitoring performance is not just because you suspect there's a problem right now, but you also need to make sure that you're not being subjective on your own, or that your users aren't being subjective, and you can have hard data to prove how the system is performing. For example, maybe 2 years ago you bought that SQL Server that you're currently using, and in the past 6 months, after you've added 500 employees, everybody's starting to complain that the SQL Server is too slow. Well, you still have to justify that it's not just everybody's perception. So what you would do is you would take, for example, a baseline that you created. A baseline is something that you use to establish the performance of a server and to identify the performance of a server at a time when everyone pretty well accepts that it is functioning properly. Then you take that baseline and you compare it against the current analysis, where after we've hired our additional 500 employees, we see that our utilization of that SQL Server has increased 50%, and that's why it's running so slow. Now we have a number that we can use to justify why we need $10,000 more for another SQL Server. And returning to the performance monitor, or system monitor, however you want to call it, when we go back into this, the way we keep track of that historical data is not through system monitor here, because this is all only real time, and it's only for the instance where we can see this little bar moving across. And as soon as I close all of this, we lose all this data. So in order to keep a permanent record, what I have to do is to go to performance logs and alerts. I could go to counter logs here, and this will just keep track of various items. And if we go to the system overview log, which is there by default, we see that it keeps some common counters within this, same ones we started with in the other item. Notice that it keeps an interval of data every 15 seconds. This is normally going to be a longer period of time than the system monitor would have been, because it'll collect over a longer period of time, and you don't want the log to get too big. This will run over a period of time and save it to a file, as you can see here by default. We'll look at that a little bit more a little bit later on. And then you can run it as, if you need to, a different identity, so you can enter in a user's name here, and then their password, so that it can run this while no one has to man the server that way. And then on the log files tab, we can specify what log file type we want. A binary file will be used for intermittent instances where we want to stop and start the log and we want to keep appending the same file. That's what the binary file will be useful for. And then the binary circular file will do the same as a binary file, except that it would also allow us to not only append data, but it will allow us to record data continuously to that same file, and then the new records would overwrite the older records on a FIFO basis. We also see that we can store it in a SQL database here, which is very useful if you want to manipulate and analyze the data in a more detailed fashion, as well as these 2 text files, which are useful for things such as spreadsheets, again, if you want to sort and look at the information using an application. Then we also see here that you can specify that file names end with a specific integer, for example, 000, here it is, 00001, starting at number 1, for example. You can also do things such as dates, which is what all the rest of these items are here. Then you can identify the location of the log file. By default, it goes into perf logs, but if you click configure, you can change a different location and change the first part of the file name, which is system overview by default for this counter, and then you can change that here as well. The log file size is limited to the maximum size of the hard drive by default, but you can limit that to a certain number of megabytes as well if you like. You'll see that from the Schedule tab that we can start and stop the log either manually using the shortcut menu, which means we right-click on this item in the background and then we choose Start and Stop respectively, or we can start it at a given time and then start it and then stop it after a given time on a certain date as well. Now that might be useful if we wanted to see exactly what our utilization was, during the weekend, and we wanted to see if that would be a good time to bring the server down for maintenance, because we wanted to see what kind of utilization it had on it, and if it was true that very few people used it on the weekend. Well, that would be a good time to use this kind of a log. Another thing you could do is to stop it after a specific number of period of time, seconds, minutes, hours, or days. And if you choose this item here to stop after a certain period of time, then when the log file closes, you can start a new log file to get the whole thing going again, or you can run a specific command. This can be, just any executable that you want, for example, or it might be a batch file that runs a net send command that says net send and then your username or the specific computer name, and it might say, the counter log is finished or something like that. Now we also need to know how to figure out how to open up those counter logs that we've archived from the past so that we can review the performance counters that we saw there. So just go back into System Monitor, and then from here just right-click on any of these items, doesn't matter which one, and choose the property, and then go to the source. And then here we're going to choose the log file, which by default is located under the perf logs directory on the system drive. So we'll locate this, and we'll click on Open. And here I just created offline here a baseline for a few seconds of some activity that had been going on. And so now we see it as a frozen kind of archived data here. We don't have a counter that ticks across. This is actual stored data from a previous counter log. And then another way to do this is to simply click this button here, which says View Log Data, and you press this item, and then you can again go right to the Source tab here and then add whichever logs you need. Now the trace log keeps extremely detailed information that you really can't even read as an administrator. You need to do is to interpret any of the output of this file, you need to look at a parsing tool. And this will be able to use APIs from providers of Microsoft providers. And you can download the parsing tools from MSDN's online library at msdn.microsoft.com/library. So again, this pretty much goes beyond our scope. What you would typically do is to keep the log and then send it to or provide it to some application developer or someone else who needs to see the extremely detailed information about how an application interoperates with one of your functions, for example. So to work with this, you right-click, choose New Log Settings, and then you enter in a name. So I'll just call it Traces. Traces of what? I don't know. But anyway, we'll just call it Traces. And then what we see here is we can have events logged by the system provider, which is actually the Windows kernel trace provider, if that means anything to you. And that would allow you to monitor all of these different kinds of things, several of which are checked by default. The default setting, however, for this trace is non-system providers, which allows you to add these kinds of providers, and there's a list of several different ones. So for example, if I wanted to keep track of every net logon activity, then I would select that item and click OK, and that would be what we would keep track of. Again, you can run this as a specific user if necessary, and then on the, I guess I better select something here, and then on the Advanced tab here, we can go to the buffer size. And what happens is a buffer is a certain portion of memory that is kind of a temporary holding area. And what will happen is when the buffer gets full, which is 4 kilobytes by default, it will then flush it out to the actual log file. If you want to flush it out more frequently, you can transfer the data forcibly every X number of seconds, like every second if you want. And then you can specify a number of buffers if you like here as well. And the reason why this kind of a log keeps track of it using buffers instead is, again, because there's such a huge quantity of data that can be tracked with this that you need buffer space in order to help performance along so that you don't sacrifice too much performance. And then you can also configure certain alerts to take place so that if an event takes place, you're notified of it, or so an application starts, or even just so that an application event log is registered. Now we'll right-click here to choose a new alert settings, and we'll just name it something. And then we'll go ahead and put in counters. Now, let's say that I want to know anytime my network utilization exceeds a certain number. So we'll go to Network Interface here, and for bytes total per second on my Intel 100 megabit per second network card, I want to track that, and I want to know anytime it goes over a certain number. I guess better go back here and click on Add for that anyway. Okay, so we've added that, and then I want to know anytime it goes over, let's just give a really small number so you can see some activity here, 100 bytes per second, which is going to happen, almost instantly. And then it will give us an interval of every 5 seconds. That's how often it will check that. We can make that longer if we want to, 10 seconds or, any other unit of time that we want it to be. And then we can specify the action. By default, it just makes an entry in the event, in the application event log. We can also send a network message to a certain person. And we can also make sure that it runs a special program. This might work in conjunction with a third-party utility, for example, that will send a message to your pager or something like that. You can also start a performance data log, which is a little bit worded incorrectly, I think. I think they should have just put on there, start a counter log, because that's what it actually does. When you select this, the system overview item, that's one of my counter logs. So that's, I think, what they should have done is to name that differently. In any case, we'll go ahead and set that up, and then you can go ahead and schedule this as well, so that if you want to, it can go it only during certain periods of time, and we've seen the scheduling before in other interfaces. So let's go ahead and apply this, and really immediately we get this message saying that on this date and time we got a message from the DC Nugget 1 to the trainer, and we notice that our 4064 bytes per second was over the limit of 100, and now we know about it, so we've been alerted. And then once I OK out of that, we see that our alerts item is still running. I don't know if you can see that, but it's green there. There it is. It gets green there, so that identifies that it is currently running. Every 10 seconds I'm getting this message now. And that's just because of normal network traffic like keep live packets and stuff like that. That's why I'm continuing to get those messages. If I'm sick and tired of this, I can just right-click on it and choose stop. And that's pretty much it. If I want to get it started again, I right-click on it and choose start again. Now note that unless you're a local administrator, if you want to monitor performance counters, you need to be a member of the Performance Monitor Users group. If you want to monitor performance counters and logs and alerts, you need to be a member of the Performance Log Users group. Now, in addition to the GUI using System Monitor to look at performance counters, you can also use command line utilities such as Logman, and this will allow you to manage and schedule performance counters either on remote systems or on local systems, and you can use that to look at performance counter or event trace log collections. You can also use relog, and that's very useful for converting event log data into another file format, such as a text file format like a comma delimited or a tab delimited format, a binary format, or a SQL format. And then you can also use tracer PT. What this does is it processes event trace logs or real-time data, and it allows you then to generate trace analysis reports and CSV or comma-separated value files for events that you generate. Then you can use type perf. What this does for us is it writes performance counter data to the command window or to some supported log file format. In this nugget, we took a look at performance, and we started off really with System Monitor, which will give you a real-time view of how your system is performing. And we looked at common counters that identify things such as your network utilization, your server utilization, such as the CPU and the hard disk and the memory in that server. And we took a look also at performance logs and alerts, and the logs are useful for something like a long-term archival basis for your performance, and that would be useful for creating something like a baseline. And then an alert would allow you to be notified if certain events take place, or would start an application or a batch file or something like that anytime something took place. For example, if you got low on disk space, it could automatically start up the disk cleanup wizard for you. WMI is Windows Management Interface, which allows you to interface with certain events that take place, and then we took a look at the command line utilities also related to performance monitoring. I hope this has been informative for you, and I'd like to thank you for viewing.